The bitwise Boolean operators allow you to perform Boolean binary operations on integer values. Here I have a working copy of bprint.cpp from Chapter 6 of the exercise files. The purpose of this file is simply to provide a quick and portable way to display binary values. The standard printf doesn't provide one, so I wrote this simple u8 to bin function to convert an 8-bit byte to a binary string. So for example here, if I just build and run this, you see this x value is 4 zeros followed by 0101, which is a binary representation of the number 5, of the decimal number 5. The decimal number 10 in binary is 1010. And so if I perform a bitwise OR, which is to set, if that bit is set in either of these two values, it results in a 4 zeros and 4 ones result. So the whole purpose of this u8 to bin function is to be able to display these binary values in a binary representation that makes it clear what's going on a bitwise level. The function itself, you can take a look at this on your own time and analyze it and understand how it works. It uses this bitwise Boolean arithmetic to actually create the string. But that's beyond the scope of this lesson. This lesson is about these specific bitwise Boolean operators. And so, for example, I have this value x, which you see is 0101. And if I use the bitwise not operator on x like this, then it'll flip all of those bits. And now where we had all zeros, we have all ones. And every place where there was a 0 in x, there is now a 1 in the result. So that's the bitwise not operator. Likewise, the bitwise and operator, it operates on a bit level. So if I say x and y, then I get this result here, which is all zeros, because there are no bits that are set in both of these two values. If I say x and 0xff, which sets all the bits, all 8 bits, then my result is exactly the same as x. Now, using the OR operator, if I say x or y, what will we expect our result to be? I'd expect it to be 0ff, or rather all zeros on the left-hand side because we don't have any ones over there, and all ones on the right-hand side because we have at least one bit set in either of those two values. So it'll be all zeros followed by all ones, and that is our result. There are also shift operators. So if I said x to shift left by 1, then our result is we have that 0101 pattern, but it's shifted over 1 to the left. And likewise, I can shift it left by 4, and it'll actually be in the high order half of the string. We also have shift right, and if I shift right x by 1, you see instead of this 0101, we now have 010, because that 1 got shifted off the end to the right. And if I shift right by 4, of course, we'll get all zeros. So these are the bitwise Boolean arithmetic operators. They allow you to perform the standard Boolean arithmetic and bitwise operations for integer values.